All right, so our uh, problem problem 6 or example 6 wants us to investigate the one-sided limits of f of x equals x over absolute value of x as x is approaching 0. So then it wants us to say, what can we say about limit as x approaches 0 of f of x itself? So it's wanting what is the limit. So in terms of the work that we're doing, we're trying to figure out what's the limit as x approaches 0 from the left of f of x. Then we want to say what's the limit as x approaches 0 from the right of f of x. And then based on those two, what's happening here, if they both exist and then they are the same, then we could say that the two-sided limit f of x is the same thing as them. But if these are different, then this one does not exist. So let's look at this one and think about what the graph of this might look. If we put a positive number in here, positive x's, like if x is 5, that would be 5 over absolute value of 5, which is still 5. So you get 5 over 5. If x was 1.8, you get 1.8 over positive 1.8. So if x is a positive number, this function gives you back 1. If x is a negative number, like negative 2, you get negative 2 over absolute value of negative 2, which is positive 2. So you get negative of the number divided by the same number, but positive. So that'll be down here at negative 1. The issue here we got to think about is if you put 0 in, this is 0 over 0, which is indeterminate form. So our function has open circles at 0. It doesn't exist at 0. But any positive number that's not 0, you'll get a 1 back. And any negative number that's not 0, you'll get a negative 1 back. So this is what our basic function looks like. So let's see. As x approaches 0 from the left. So as we approach 0, we get close to 0 from the left-hand side. Our y values are going to be along this bottom line. So they'll be approaching negative 1. As we approach 0 from the right-hand side, we're approaching, x's approach 0 from the right. So we're approaching up here from the right-hand side, we're approaching positive 1. So we get our two one-sided limits. One of them's at 0, one of them's negative 1, the other one's positive 1. But the two-sided limit does not exist. And the reason is the one-sided limits, we could say the left and right-hand limits, were not equal. So that's the reason. The two-sided limit doesn't exist because the left and right-hand limits approach to different numbers. So let's scroll on down here and take a look at example 7. So example 7 gives us in the textbook, they give us a function by giving us its graph. They tell us the function's not defined at c equals 0, 2, or 4. They want us to find the one and two-sided limits of our function at all those points. So what they're asking us to do is, what is the limit as x approaches 0 from the left of our function? What's the limit as x approaches 0 from the right of the function? Then what's the two-sided limit at 0 of the function? Then they want us to do the same thing for 2. It's the limit as x approaches 2 from the left of the function. What's, stop drawing, come on. Stop it. Oh, great, now that's staying there. Hang on just a second. So what's the limit as x approaches 2 from the left of the function? What's the limit as x approaches 2 from the right of our function? What's the two-sided limit? Then we want to do the same thing for 4. Limit as x approaches 4 from the left. of our function. Limit as x approaches 4 from the right. And limit as x approaches 4. Okay, so as we approach 0 from the left, we're in this half of the graph where we have things wiggling back and forth too much. It's bouncing back and forth between 1 and -1. So this does not exist. As we approach 0 from the right, we're approaching 0 from the right, which says we're going to be coming down on this. So we get the value, we're approaching 2. Well, the left-hand limit here does not exist, so the two-sided limit can't exist. Or you could say does not exist and the number 2. Those aren't the same thing, so we can say two-sided limit does not exist. Again, for this two-sided limit to exist, both the one-sided limits need to exist. Since the left-hand one didn't, we were already done there. And then if they do both exist, they need to be the same number. In this case, one of them didn't exist, so the two-sided limit can't. All right, let's see. As we approach 2 from the left, so as we get close to 2 from the left, our y values are up here on this part, so we get 3 back. As we approach 2 from the right, our y values are along the this little bit here of the graph, so they're approaching 1. So this time both the left and right hand limit exist, but they are not equal, so the two-sided limit does not exist. And finally, as we approach 4 from the left, so we approach 4 from the left, our y value is 2. So we approach 4 from the right, the y value is 2. So both the one-sided limits exist, and they're both 2. So since both the left and right limit exist, and they're both 2, the two-sided limit exists, and it's 2. And that will wrap up example 7. That's all it wants us to do.